Okay, hi guys. Today we are doing the last bit of integration, which is anti-differentiation. Now, I want you guys to remember that we have already discussed anti-differentiation. It is just the opposite of finding the derivative. So what we did for that, you can just write it next to your heading. For anti-differentiation, if you have something like this, the integral of, let's say, x to the 4 plus 2x cubed minus x, right? And you have to find the integral, or the antiderivative of that. What we did in this case is we would take each term separately, and we would say that if we have x to the 4, the integral of that is going to be x to the 5 over 5. So we add 1 to the exponent and then we divide by that number, that exponent. Then we're going to say plus 2x to the 4 over 4, right? Which obviously this can be simplified. The last one we're going to say minus x squared over 2. And then we need to add that constant of integration, which is just plus c, because we know that if we have a constant term, the derivative of a constant term is 0. So it wouldn't appear here. So we need to just show that there might have been a constant term. There's just no way for us to know whether there actually was one or to know what that constant term was. So that's why we say plus c. Right. So that is what we did previously with anti-differentiation. Now we need to figure out what's going to happen if we have numbers at the ends of this integration symbol. Okay, because this now can be read as the area between this function and the x-axis. But now we need to know from which x value are we starting and at which x value are we ending. Okay, so I have some examples here. We're going to try and like generalize and see if we can figure it out till we get to that final one at the end there. All right, so if we have the line y equals 1, so this is our function, and we're going from where x is 0 to where x is b. Okay, if we need to find the area for this, we can see that this is a rectangle. Okay, and what would this length be? The length from 0 to b would be b, and the width, or the height if you want to call it, of this rectangle would be from 0 to, now what is that y value over there? That y value is actually 1. Remember, every point on this line y equals 1 has a y value of 1. So this length is actually going to be 1. So this is b, and that is 1. So what would the area be here? Length times breadth, b times 1. So the area would actually be, sorry, I said 1. B times 1 is not 1. B times 1 is b units squared. So b units squared. But you also could have just used integration for that. So you could have said it is equal to the integral from 0 to b of 1 dx. Now what is the integral of 1? Remember that 1 is the same as 1x to the 0, or just x to the 0 actually. 1 is the same as x to the 0. So if we had to find this integral, right, we would add 1 to the exponent and then put it over that exponent. So this integral will actually be x to the 1 over 1. Right, so this integral is x. And how do we go from x to getting a final answer of b? Actually, I want you guys to write this with curly brackets. Not curly, square brackets, I mean. Sorry, that was my mistake. Right? You can put those values there. Now, basically what this means, you'll see it in more detail when we get to the next examples, I think. But what this means is that we're actually going to have to sub in these x values that we're given. In this case, the x value is b. Now, if we're subbing in b for x, what do we get? If x is b, then this is just b. All right? And if x is 0, then this is just going to be 0 as well. So you'll see in more detail when I get to the next examples. But we're actually going to sub in that value. Right, and that will give us b units squared. Sorry, I'm sure that's a bit confusing at this point, but yeah, I'm hoping that this can lead us to getting there in more detail. Okay, we have y equals x. Remember the line y equals x, each point will have the same x and y value, right? So you can have a point 1, 1, 2, 2, 3, 3, 4, 4. What is the x value at this point? X value at this point is b, meaning that the y value is also going to be b. Right? So this is actually the point b. Now this is giving us a right angle triangle. So if we want to find this area, we can approach it in that way, and we can say that the area of a right angle triangle is a half base times perpendicular height. What is the length of the base? In this case, we're going from 0 to b, so the length of the base is b. And the length of the perpendicular height, again from y equals 0 to y equals b. So this height is also b. Right, so the area here, if we're approaching it as if it is just a right angle triangle, is going to be a half base, which is b, times perpendicular height, which is b. So a half b squared. Right? But this is actually also what we're going to get if we take the integral of this function. So then we're going from 0 to b, and this function is x dx. And what is the integral of x? X over 2, or x to the 2, sorry, x squared, so we add 1 to the exponent, over that same exponent, x squared over 2, which is the same as a half x squared. Right? But we want to get to a half b squared. So again, we're going to have to sub in that b, we're going to have to sub in that 0. Okay, if we're subbing in b for x here, we're going to get b squared over 2. If we're subbing in 0 for x, we're just going to get 0. Alright, so here we're going to have b squared over 2, which is the same as a half b squared. Okay. Now, if we look at the next two examples, I'm working with a parabola here in both cases. In the first example, we are again going from 0 to b. In the second example, we're going from a to b. All right? So here, if we're going from 0 to b, now there isn't actually a way for us to find this area unless we approach it from like a rectangle perspective, okay, if we use a Riemann sum. Or what did we find out now in the previous few lessons? That area is the same as the integral. All right, so if we want to find this area, we're going to say that it is the integral from 0 to b of x squared dx. And now we remember that to integrate this, we're going to add 1 to the exponent and then divide by that exponent. So put it in square brackets, and the reason for that is just that is the notation that we use. Okay, we just always put it in square brackets. And now we have a b at the top and a 0 at the bottom. And what are you going to get if you sub in b for x? You're going to get b cubed over 3. Now I just want to show you guys quickly in the answer series book. I actually have the whole working of this, which I'm not going to write down now. But there they have the graph, and they've actually done the entire Riemann something for getting this area. All right, there they have limit as n tends to infinity, and there they're getting that the area is b cubed over 3. All right, and then they're saying that if you used y equals x cubed, you could use the same method to show that the area is b to the 4 over 4. And then they're using that to prove this whole anti-differentiation formula, which we already have. Okay, so they're saying if you're going from 0 to b, then this is going to be your area. X to the power of n, whatever that n is, whatever that exponent is, you're going to take b, so you're subbing in b for x, and you're taking b, and you're adding 1 to the exponent, and then you're dividing it by that same exponent, and that will give you the area. Okay. Now they're saying, I want you to ignore this bit at the bottom, They're saying there, this reminds us of differentiation. Integration is the inverse operation to differentiation. It is often referred to as anti-differentiation. We have done this already as well, okay, because they're saying that the derivative of x to the n plus 1 over n plus 1 is going to give you x to the n. All right, so they're just basically proving what we did last year already. Okay, so don't worry about that now. But now we need to talk about if the lower boundary is not 0, okay, which is this last diagram that I have here. So we have the same graph. We again have y equals x squared, but now we're going from a to b, not from 0 to b. Okay, all of these were quite straightforward, the first three, because every time our lower boundary for x was 0. Now we have a different lower boundary. Now, if we're trying to find this shaded area, I hope it should make sense to you guys that we're going to take this entire area, so from 0 to b, and then to get rid of that small area there, we're going to have to minus the area from 0 to a. Okay, so the area from 0 to b is this, b cubed over 3. And then we're going to minus the area from 0 to a, which is going to be a cubed over 3. So we're going to say area, shaded area in this case, is going to be the total area from 0 to b. So 0 to b of, what is this function again? X squared dx. And then we're going to subtract this small, the white area in the front, because we just want the shaded area. So we're going to subtract the area from 0 to a of x squared dx. Okay, which is the same as doing this x cubed over 3 is 0 minus x cubed over 3 a to 0. But what does this simplify to? This simplifies to b cubed over 3 minus a cubed over 3. Now, instead of doing it as two separate integrals, like we've done it here, for simplicity's sake, what we're actually going to do is, just grab the black one. We're going to put it all together in one. We're kind of going to combine these two. Instead of saying that I'm going from 0 to b and then from 0 to a, I'm going to say that I'm going from a to b, because this is actually what we're looking for, right? We want to do it in as few steps as possible. So we're going to do this. Remember, we're trying to get that b cubed over 3 minus a cubed over 3, because that is what the area is. We're going to say, therefore, area is equal to, instead of working from 0 to b and 0 to a, like I said, we're going to go from a to b. So a is our starting x value, which it is, right? We can see that in the question. So a is our starting x value, b is our final x value of x squared dx. I'm going to put that in our square brackets. The integral of x squared is x cubed over 3. We're going from b to a. And now in order to use this to get to b cubed over 3 minus a cubed over 3, we are going to substitute the final x value, which is b, into our function. So we're going to say b cubed over 3. And then we're going to minus, because we wanted to get rid of that part of the area. So we're going to minus the same function, the same integral, but now I'm going to sub in the beginning x value, which is a. Okay, so that might be a bit confusing at this point. We are going to do numerical examples now as well, so that you can see how it works when we're working with numbers. But that's basically what it comes down to. If you need to do a definite integral, all right, definite integral, because we are given a beginning x value and a final x value, you're going to do your normal anti-differentiation. You're going to write it in square brackets, put your A and your B values, whatever those are, at the ends. And then to get that actual area, you're going to find the difference. So you're going to sub in B to get that area, and you're going to minus where you're subbing in A to subtract that area. And you will be left with the shaded area. Okay, we'll do some examples quickly. I would like you to write these down. Sorry, I didn't actually put these ahead of time. I meant to. Okay, so examples. Now these ones are all done without the use of a calculator. So if they're asking you for an integral and they're not saying that you're not allowed to use your calculator, you're going to just type it in using that integration or integral button. If they're saying that you need to show all your steps and that you need to do it without the use of a calculator, then this is what you'll do. Okay, so number one, I should just add that at the top. So this is if they're saying without calculator. Okay, otherwise you just type it in. Right, the first thing is from 2 to 4 of x cubed dx. Right, we're asked to find the integral from 2 to 4 of x cubed dx, or you can think of it as the area between the curve y equals x cubed and the x-axis from where x is 2 to where x is 4. Right, they can ask it in that way as well. They can ask it as an area question, and you must then set up your integral and then find the area like that. So now what we're going to do, we're going to use our square brackets first, and we're actually going to find the integral of this, the antiderivative. So we're going to say x to the 4, we're adding on to the exponent, and then we divide it by that exponent value, by that 4. And now we put our b value at the top and our a value at the bottom. Now from here, we're going to sub in our b value first. So we're going to say 4 to the power of 4 over 4. So 4 is there. Minus, we're going to take this function and we're going to sub in 2 for x. 2 to the 4 over 4. Guys, if they're asking you to show all your steps and to do it without the use of a calculator, you are going to have to show the step. All right, this is showing that you understand that you need to sub in 4 and then sub in 2 and find the difference between the two. Okay, this you can now type into your calculator and it will give you 60. Okay, easy enough, I hope. Number 2, I'll just do it on the side there. We have the integral from 1 to 3 of 4x squared dx. Okay, so again, we're going to do our square brackets. We're going to do the integral first. So remember, when you integrate, you just write the 4 in front. So you can write it in front of the whole fraction, or you can write it in the numerator. Now we're actually just going to integrate the x squared. So the integral of x squared is x cubed over 3. Right, and then we go from 3 to 1, or from 1 to 3 rather. And now in our next step, we're actually going to sub in these values. So we're going to have 4 times 3 cubed over 3 minus 4 times 1 cubed over 3. Right, so you just sub these values in for x. And then you type that into a calculator and it will give you 104 over 3, or if you want, you can write that as 54.67 units squared. Okay. Just want to do one where we have more than one term. We need to integrate. So if we are going from 0 to 2 of 3x squared plus 4x plus 1 dx. Okay, now we need to find the integral of all of these terms. So we're going to put the 3 in front again, and the integral of x squared is going to be x cubed over 3. Now obviously those 3's are going to cancel each other out. So it's actually just x cubed. Then plus 4, and now the integral of x is x squared over 2, and now again 4 and 2 will cancel out. I'm just going to be left with 2x squared, and then plus integral of 1. Remember, 1 is the same as x to the 0. The integral of x to the 0 is x to the 1 over 1. So that is just x. And this is 2 and 0. If you want, you can just rewrite this in its simplest form. So x cubed plus 2x squared plus x, and then 2 and 0 like that. Now we're going to have to sub in 2 into each of these, and then minus subbing in 0 into each of these. But what's going to happen now if we actually sub in 0 into each of these? Each of these terms will just be equal to 0. So this is like one of those previous ones where if your a value is 0, you actually don't have to minus that. Okay, you can write that in if you want, but it's not actually going to change your answer. So I'm going to write it in just so that you can see what happens. So we're going to have 2 cubed plus 2 times 2 squared plus 2. And then we're minusing where we're now subbing in 0. So 0 cubed plus 2 times 0 squared plus 0. Okay, but like I said, this whole thing is just 0. And that will always be the case when you're working with these integrals. If your beginning border or boundary, the x value is 0, then it will just make your whole expression 0. So you actually can just sub your final boundary. Okay. And this will give you an answer of 18 units squared. There you go. Now, I haven't actually mentioned, but I hope that you guys noticed that I didn't put in a constant of integration for any of these. Okay, now you can if you want to, but it is practice to not do that, because when we do this, when we are minusing, right, if we had an x to the 4 over 4 plus c, now you're subbing in your final x value, which will be 4 to the 4 over 4 plus c minus 2 to the 4 over 4 in brackets plus c. All right, those two c's will cancel out. So that is why when you're doing a definite integral and we're subbing in these values, you don't say plus c, because your plus c in your first expression, where you're subbing in your final x value, will be subtracted when you are minusing that expression where you're subbing in your beginning x value. Okay, so that is why for definite integral, we don't actually write down that constant of integration. Okay, I want to do one last question here, one last example where they flip it around a bit. So number 4, they ask you to determine the value of p given the integral from 0 to p of 6x squared dx is equal to 54. All right, so now they haven't given us that final boundary, our final x value, but they've given us the value of the actual integral. Okay, so if we were to calculate this, we would do this whole process, hey? So we would say that square brackets, integral of 6x squared is 6x cubed over 3. And then we're going from 0 to p, and that now is equal to 54. That is the value that they've given us. Okay, now 6 and 3 will simplify, obviously, so we'll actually get 2x cubed. P and 0 is equal to 54. Now what's nice in this case is that our first boundary, our lowest x value, is 0. So what do you think we're going to have to do in order to find p? We have to sub in this p value, right? And then make it equal to 54. So we're going to have 2p cubed. And if you want, you can say minus 2 times 0 cubed, but again, that is just going to give you 0. And that is equal to 54. Okay, so we actually have 2p cubed equals 54. And now we just need to solve for p. So now we're going to say p cubed is equal to, what's 54 divided by 2? 27. So what is p? 3. All right. So from here, we can say that this integral, if it was going from 0 to 3, and we were finding the integral of 6x squared, we would get an answer of 54. Okay. Your homework for Monday is going to be, and again, this is from the answer series, so I will just post this on the group. It's going to be exercise 12.7 on page 145, and I want you to do the whole exercise. It's not long, it's just finding these integrals. And then also from the exam questions, let me just take a look. So this is grade 11 exam questions. Okay, now that whole exercise also starts on page 135, but I would like you to do numbers, let's see, 5, number 5, 9, and 11, and 12. And then that is it for integration. Thank you guys.